Hello, confused physical chemistry students. My name is Jasmine Shellman, and I'm about to explain to you the JaBLONski the JaBLONski diagrams. So first, we have three states. We have the singlet ground state, the singlet excited state, and the triplet excited state. All right. The singlet ground state is noted by S sub 0. The singlet excited state is S sub 1. And the triplet excited state is S sub 1. So let's start when the photon is first absorbed. Yeah, see it shooting up. It can shoot all the way up to the singlet excited. It could, shoot to the top level of the singlet ground state. It doesn't matter where it shoots off. All that matters is the amount of energy. So let's move on to the second stage. This little swivel, we call that a vibrational relaxation. It could relax all the way from the top to the bottom. It could relax all the way down to where we're looking at this green line being drawn, which is actually a display of fluorescence. Fluorescence is very high in energy. It's only when it goes from one, like an excited state down to another excited state. Oh, well, a singlet to a singlet. So I erased that yellow line, that yellow swallow. But when it goes from the singlet excited state to the triplet excited state, we call that an internal crossing. So basically, these processes that I'm showing you right now, they can only happen from this state to this state. This little red mark that you just see that just got drawn, that's the photon conversion. It changes, flips. And we have another vibrational relaxation right here. This can also occur in any of these states. And this step right here, from the ground of the triplet excited state down to the ground of the singlet ground state, it's called a phosphofluorescence. It's lower in energy than a fluorescence, and it is a much slower process. So now I'm going to give you guys some, compare and contrast, so you guys can know the difference between a fluorescence and a phosphofluorescence. I'm not gonna lie, I recorded this video 3 times. This is my third, so I already have some notes on the differences. For starters, fluorescence is higher in energy than phosphofluorescence. The reason being, the photon drops a longer distance than that of phosphofluorescence. This is also why phosphofluorescence is a slower process, and the light takes a little longer to dissipate. Next, fluorescence, it only happens in singlet states. It will never happen from a triplet state. But they both release energy. Phosphofluorescence, because it's higher in energy, fluorescence, because it's higher in energy, will also correspond to another color on the spectrum. That color is blue. Blue burns hotter than red.